Normalization in machine learning. AI intermediate level. Introduction. In machine learning, datasets often contain features with very different numerical ranges. For example, feature range: age 18 to 60, income 20,000 to 200,000. When features have different scales, machine learning algorithms may give more importance to larger values, which can lead to incorrect learning. To solve this problem, machine learning uses a technique called normalization. Normalization rescales feature values to a fixed range, usually between 0 and 1. It is commonly used in machine learning tasks such as recommendation systems, image processing, neural networks, clustering algorithms, distance-based models. Understanding normalization helps learners build more balanced and stable machine learning models. What is normalization? Normalization is a feature scaling technique that transforms numerical values into a fixed range, typically between 0 and 1. In simple words, normalization equals rescaling data so that values fall within a small, consistent range. Example concept: large numeric range means normalization means values between 0 and 1. After normalization, all features have comparable scales. Why normalization is important? Machine learning algorithms often rely on distance calculations or gradient-based optimization. If one feature has very large values compared to others, it can dominate the learning process. Example concept: large feature values means dominate learning means biased model. Normalization helps balance feature contributions, improve model accuracy, speed up training, stabilize optimization algorithms. It ensures the model treats all features equally. Min-max normalization. The most common normalization method is min-max scaling. This method rescales values between 0 and 1. X equals frac x, x underscore min x underscore max x underscore min, where x equals original value, x m I n x min equals minimum value in the dataset, x m a x max equals maximum value in the dataset, x single quote equals normalized value. Example concept: original value range means transformed range, 0 to 1. This ensures all feature values fall within the same range. Example of normalization. Example dataset: income 20,000, 50,000, 200,000. After normalization, income normalized 0.0, 0.17, 1.0. Example concept: raw dataset means normalized dataset. The values are now easier for algorithms to process. When to use normalization? Normalization is particularly useful for algorithms that depend on distance measurements. Examples include k-nearest neighbors, KNN, support vector machines, SVM, k-means clustering, neural networks. Example concept: distance-based algorithms means benefit from normalized data. These algorithms perform better when features have similar ranges. Normalization versus standardization. Normalization is often compared with another scaling technique called standardization. Method range typical use. Normalization 0 to 1 distance-based algorithms. Standardization mean equals 0. STD equals 1 algorithms assuming normal distribution. Example concept: normalization means fixed range. Standardization means centered distribution. Choosing the correct method depends on the dataset and algorithm. Advantages of normalization. Normalization provides several benefits. Advantages include: ensures balanced feature influence, improves convergence speed of algorithms, stabilizes gradient-based learning, helps distance-based algorithms perform better. Example concept. Balanced feature ranges means improved model training. Normalization is widely used in deep learning and clustering algorithms. Limitations of normalization. Despite its advantages, normalization has some limitations. Limitations include sensitive to outliers, requires recalculation if new data changes the range, may not work well with normally distributed data. Example concept. Extreme values means distort normalization scale. In such cases, standardization may be preferred. Example Python code. Normalization can be implemented using scikit-learn. Import the scalar from sklearn. Preprocessing import min-max scalar. Apply normalization. Scalar equals min-max scalar. X underscore scaled equals scalar dot fit underscore transform. X. This converts all feature values to the 0 to 1 range. Normalization workflow in ML. Normalization is typically applied during data preprocessing. Example workflow. Raw dataset. Down pointing arrow. Data cleaning. Down pointing arrow. Feature engineering. Down pointing arrow. Normalization. Down pointing arrow. Train machine learning model. It ensures the dataset is properly prepared for training. Real-world applications. Normalization is used in many AI systems. Image processing. Pixel values are normalized between 0 and 1 before training neural networks. Recommendation systems. User behavior data is normalized to improve predictions. Finance. Financial indicators are normalized before training prediction models. Healthcare. Medical measurements are normalized for disease prediction models. Marketing. Customer behavior metrics are normalized for machine learning analysis. Concepts learned from normalization. Understanding normalization helps learners understand. Checkmark why feature ranges affect machine learning models. Checkmark how min-max scaling works. Checkmark when normalization should be used. Checkmark how scaling improves model performance. Checkmark how preprocessing improves machine learning results. Normalization is a fundamental technique in data preprocessing and feature scaling. Simple definition. Normalization. A feature scaling technique that rescales numerical values to a fixed range, usually between 0 and 1, to improve machine learning model performance. Final summary. Normalization is an important preprocessing technique in machine learning that rescales feature values into a consistent range. By transforming data into values between 0 and 1, normalization ensures that features contribute equally to machine learning algorithms. This technique is especially useful for distance-based algorithms such as KNN, SVM, and clustering methods. Understanding normalization is essential for building stable, accurate, and efficient machine learning models.